Okay, in this last part of the notes for section 8.3, we're going to learn how to write the equation for an ellipse given some different information. Things to keep in mind is that A is always the major axis distance, and it goes with the vertices, and B is always the minor, and it goes with the co-vertices. So A is always larger than B. You also want to remember that C is going to equal A squared minus B squared. And then the last thing to remember is that A is always going to go underneath the variable X or Y that it is associated with on the graph. So a good strategy for some of these problems might be graphing for you. Okay, write the equation of an ellipse that has this as a center. So I'll start off with writing that in with X minus 1 squared plus y plus 2 squared. It has a major axis of 8 that's parallel to the x-axis and a minor axis of 6. So when it tells me that the major axis is 8 and it's parallel to the x-axis, I know that the major axis is going to be longer in the horizontal direction and it'll be smaller in the vertical direction. So if the major axis is 8, that means the distance from the center to the vertex is going to be 4 on each side. And so I know that 4 is going to go underneath the x's, but I'm not going to write 4. I'm going to write 4 squared, which is 16. Then the minor axis has a length of 6, so this distance is going to be 3. This distance will also be 3, and I know that I'll write 3 squared underneath the y's, or the vertical direction. And then we always plop a 1 over here, and this problem is finished. That's the equation that they're asking for. For the next question, I think the best way to attack this is to go ahead and graph it. So it has a center at 3, -2. It has one vertex at 3, 4. That's a vertex. And a co-vertex at 1, -2. Now I don't need to graph the entire ellipse out. I can using symmetry, but I don't necessarily need to. All I really need to know from this information that this is a vertical ellipse, and that this major axis has a value of 1, 2, 3, 4, 5, 6 for an A value, a total length of 12. And the B value is 2, or a total length of 4. So when I get ready to write my equation, x minus 3 all squared, y plus 2 all squared, I automatically can take these values now and put them underneath the variable that they're associated with. So because 6 is in the vertical direction, I'll put 36 underneath the y's. And because 2 is in the horizontal direction, I'll put 4 underneath the x's. And then that is your final equation. And finally, the third problem here, we have an ellipse with vertices at 0, -2, and 6, -2. Now, I don't know what the center of the graph is, or the ellipse is given from the given information, but now that I've put the vertices on the graph, I can automatically find out that the vertex is right here. Not the vertex, I'm sorry, the center. It's always in the middle. I also know that this information is helpful. I'm going to have to do some algebra in order to find the co-vertices. So first, let's get started with writing our equation. X minus, let's see, this value here is 3, -2. So x minus 3 squared, y plus 2 squared equals 1. Remember that this is the major axis, the one that has the vertices on it. I know that the value from the center to the vertex is 3. That's in the horizontal direction, so that'll go under the x's, 3 squared. All right. Now I don't know how far I need to go in the co-vertice direction, but I do have this focus value of 2, -2, and 4, -2. So I know now I have the C value. Remember, C is always the distance from the center to the foci. So this tells me that C is 1. So using the equation C squared equals A squared minus B squared, I know that C is 1, A, remember, was 3, and I don't know what B is. I can solve this equation with some simple algebra, and I find that B is the square root of 8. Now, whatever B is, when I put it underneath the equation, I always write B squared. So if I take root 8 and I square it, I'm going to get a value of 8. And that's what goes in my equation. And we are finished.